Alright, so this is number 1 from section 10.2, the first type of problem, which is really just finding the derivative dy dx of a parametric set of equations. Now to do that, we're really just employing this formula written in orange here. And a little bit of background as to how to find that formula. It's really not too difficult before we even get into the problem. Basically what you're doing is you're saying, okay, well we know y to be a function, a differentiable function of x, and we know x is a function of t. And from there, if we were to take the derivative dy dt, right, so y is being a function of t, we would find that we would just use the chain rule, right, as a direct result chain rule, dy dx, and then dx dt. And you can even see if you were to cross these out, it's the same. So that holds, and it's just chain rule. And then from there, you would divide over by this dx dt term, and then you would get the expression in the formula. Okay, so that's a little bit of background as to how we get that formula. But now onto the actual problem. I'm going to start with the numerator in the formula, so this portion, the dy dt, and I'm just going to compute that. So dy dt. So we're taking the derivative with respect to t of this function. Now to do that, all we really need to do is power rule. The derivative of the inside is just 1, so technically chain rule, but it doesn't really affect it too much. So just by doing the power rule, we get that, or putting it all in the denominator and rewriting it as a root, we get that. Okay, so that's the derivative of this portion in the formula. And now we're just going to do the second portion, the dx dt. So dx dt. Okay, so this one, this is our x. We're referring to that thing right there. And we're just taking the derivative of that with respect to t. So this is a quotient, so we have to do the quotient rule. So derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. So let's just clean this up a little bit. When we factor that out, I believe we just get 1 at the top and then 1 plus t squared. Okay, so now we've got our two different parts in the formula. We've got the numerator and the denominator. And then from there, I'm just going to plug them in. So the dy dx, and this is our final answer once we clean it up a little bit, is 1 over 2 root 1 plus t over 1 over 1 plus t squared. Okay, and this is a complex fraction, so we can multiply by the reciprocal to divide, and that would just leave us with 1 plus t squared over 2 root 1 plus t. And then just final step, this is the power of 2, this is the power of 1/2 if we were to write it in that form, so we can do 2 minus 1/2 to just get that 1 over 2, well, here, let me write it like this, 1 plus t to the 3/2 over 2. And this is our final answer, and this was our dy dx. Alrighty.